So we're going to finally end this by quickly talking about seasonal averages and how we can calculate out errors in any of our data, actually, no matter what we're doing. So seasonal variations in data are basically revolving around something that happens, seasonally. Weekends, summer breaks, holidays. A good thing for a seasonal forecast would be something like a ski slope that they maybe do some hiking and camping in the summertime. That's going to have a lot different demand than when it's in the height of winter when people can go out and ski. And so seasonal forecasts are really just a modification of our other forecasting methods. So basically we want to first determine the number of seasons, which we'll call S. And then we'll calculate out the average demand for each season. And so that's going to be our A sub S number with the bar on the top for averages. And so let's take the example of our ski slope. So we probably have a skiing season and then we have a non-skiing season. So the skiing season, we can calculate our average demand from historical data on how many people come to visit our ski slope during the winter. And then the other 9 months a year, we have our camping time, and we can calculate out what's going on. And so then what we do is we calculate out the average demand across all seasons. And so basically we just take each of these season demands that we came up with, we add them up together, divide by the number of seasons, just to tell us what the normal regular average is across the entire year. And so the reason that we do that is so we can create the seasonal index. And so basically the seasonal index is just a relationship between our average, what our average seasonal demand is for each season, divided by the overall average. And so this would be our IS number. And so this can be any place all over the place, because you would figure that for a ski slope, the seasonal index for the winter would be higher than would be in the summer. Would be higher than 1, because we're figuring that the average during ski season is going to be a lot higher than what the average is across the entire year. And so really those first 4 steps are the big thing for calculating out how we do how we calculate out seasonal forecast. Because basically then what we do is you figure out what your forecast is using another method. So using one of those weighted average or moving average or exponential average. You use one of those and then you apply the seasonal index to that formula. So basically our seasonal formula is going to be our seasonal constant or seasonal index, and then we're going to take our forecast and just divide it by the number of seasons. And so that's really all there is to it. It's really kind of a subset of the other ones. The other 3 are the big important ones. So the last thing that we need to talk about is our forecast errors equations. And you're going to see this quite a bit. We're going to do this in not only this class, you'll see this again if you end up doing anything with statistical data. You're going to need to be able to calculate out error. And so we have 3 different ways that we can calculate out error. The first is the mean absolute deviation, or MAD. And so what is that? Well, if I look at the equation, this is telling me my MAD is going to be the absolute value of what my actual demand is minus my forecast demand divided by the number of data points that I've got. And the reason that this is an absolute value is so this will always be positive. And what this is going to do, it's going to calculate out how far off we are absolutely in regular numbers. We have the mean squared error, the MSE. It's pretty much a very similar equation, except instead of taking the absolute value, we're going to square the numbers. By squaring it, we're always going to be a positive number, so we don't have to worry about the absolute value. And the last one is the mean absolute percentage error. So this first one gives us a number value. Oh, our mean absolute error, we're off by 1 unit. We're off by 2 units. Mean absolute percent error, the MAPE, is going to give us a percentage error. Because if you look at it, here we go. Same, the only difference between MAPE and MAD is that we're dividing this one by that actual demand. So that's going to give us a percentage deviation. And let's just take a look at, so if I'm looking at them, so the mean absolute deviation, what is that doing? That's telling us how much the forecast missed the target. And if you look in your book in example 4, they were talking about grain, and so they were off by 10.31 tons. So it's an actual physical number. So what is the mean squared error? It's the square of how much the forecast missed. Now this one's a little bit different because, okay, well, we get a square of 190. What does that number mean? Well, it doesn't mean anything. Okay, then why do we do it? It's a way that we can compare mean squared errors from other problems. And so we're comparing apples to apples at that point because we're looking at the square of all the errors, and it helps average out some of the differences between things. But this one's the one that's a little bit different because it doesn't correspond to something other than just a comparative index as we're looking at other numbers. And so the mean absolute percentage error, that is the average error by percent. These are all going to be useful ways of looking at our data. These are all going to be useful ways of how we gauge how well any of our fits from our forecast, whether it is from the 3-month moving average or whatever month moving average, the weighted moving average, the exponential smoothing, or when we get to it, when we do the regression. And we'll be using these a lot with regressions to test how well our regression equations compare to reality. Okay, and that's all of the statistics that we have and all of the methods that we have for Chapter 4 in our book.